to start by using the vertex formula to find the two coordinates of our vertex. So that's what we did on Thursday. So remember, to find the x coordinate, and we'll do some examples of these, you use the x is equal to negative b over 2a to find your x coordinate. So your x value. Then you take that value, you substitute it into the trinomial to find the y coordinate. Right, so it's kind of the two steps. We're going to put that vertex point in the middle of our table, and we do that because we can find values for x that are around our vertex, so we know we'll have points that we're able to plot. It also makes us quicker because if we are using our vertex and we know about the symmetry in our tables, we only have to evaluate for half of a table instead of doing a full table. And that's the step here. We're going to evaluate to find our y values. So these are good because it'll be a little bit of a review from Thursday as well as we do these problems. So we're graphing this first equation, x squared plus 2x minus 8. We know we're going to start by finding the vertex, so we know we need to know what our a and our b term is. We have a coefficient of 1 in front of our x squared, so our a term is 1. And then we have a 2 for our b. I'm going to do my work for the vertex just below the box here because that's where I left the space for it. So I'll label this. This is all the steps that I'm doing to find my vertex. So first I need to find the x coordinate. So I'm using the formula x is equal to negative b divided by 2 times a. And we focused a lot on Thursday about just when we're plugging things in, being conscious of using parentheses. So when I plug this in, it's going to be a negative from this negative. And now I'm plugging in b. So my b was a positive 2. Then I'm taking 2 times my a term was 1. So I'm plugging in 1. If I simplify the top and the bottom, then reduce, this would just be a negative 2. Again, you can always think of as a negative 1 times 2 gives us negative 2. We're going to end up dividing it by a positive 2. So our value is going to be equal to negative 1. And I'm going to label that with an x since that's my x coordinate. So just this line here to separate kind of step 1 and step 2, finding my x value, now finding my y value. We need to use our original trinomial we're given. So I am going to rewrite that. X squared plus 2x. And then it was minus 8. So like the step said, we're using our value that we found. And we're substituting that in for x. All right, so anything where we see an x, we're replacing with a negative 1 in parentheses. So we'll say y is equal to negative 1 squared plus 2 times negative 1 minus 8. To simplify, we follow order of operations and combine like terms when we're all done with that. This would be negative 1 squared would be positive 1. We have 2 times negative 1, so that would be negative 2, or 1 minus 2. And then we have minus 8. So simplifying that whole bit there, we get y is equal to negative 9. All right, and that's our y value. So that's what we did on Thursday. That's all we practiced on Thursday. Now we're going to do the part where we kind of fill in our table. We're going to find the middle row, and that's where our vertex points are going to go. So our middle row would be 3 on the top, 3 on the bottom. So this fourth row down. Our x value was -1, so I'm going to put a -1 here. Our y value was -9, so I'm going to put a -9 here. And just in the space in between here, so we know, I'm going to write vertex. And all the ways I've ever tried graphing, using your vertex as the middle point in your table is by far the best. To fill in the rest of these x values, we're just going to count forwards and backwards to fill in the rest. So counting forwards, it would be -1. Here would be 0. Here would be 1, and here would be 2, right? Just like on a number line. Think if we're filling in the number line with all of these values of x. So -1, 0, 1, 2. So to fill in the rest of the table, we're just going to count backwards. So everything less than -1. So we would go -2, -3, -4. When I'm picking out what I want to start evaluating with, I'm always looking for positive numbers and I'm looking for small numbers. That just makes it easier. I'd much rather plug in a 0 and 1 than a -2 and a -3. So I'm going to plug in 0. So just like we did to find what -1 is, we plugged in -1, we got out a -9. We're going to plug in 0 and see what we get out. The space in the middle is just intended to show, is there for you to show that you're plugging in 0. So writing, let's say, like we're taking 0 squared plus 2 times 0 minus 8. Whatever that equals is my y value for that row. So 0 squared is 0. 2 times 0 is 0. So we're going to just have a 0 minus 8. So our answer, or our corresponding y value, is -8. All right, we have another point that we can graph. We'll just go down to the next one. We'll do 1 squared plus 2 times 1 minus 8, and we'll evaluate that. Again, if you have one of the kind of fancy scientific calculators, you could type this just like this into your calculator. It would do all the simplifying for you. If not, just follow order of operations. Exponents, multiplication, then do adding and subtracting. So evaluating this out, we would have 1 plus 2, which is 3. Then we minus 8. So 3 minus 8 gives us -5. So we put a -5 here. We do the same thing for our x value of 2. 2 squared plus 2 times 2 minus 8. This will be 4 plus 4. So we get 4 plus 4 is 8. Then we take 8 minus 8. That's equal to 0. So our last box is a 0. So why we chose to do the vertex first is so we could do this. Remember, in a parabola or in a quadratic, we have symmetry. So around our vertex, things are going to be the same. So I don't have to go through and do my work for these three. I could just use the values that I already found. I know that the output for -2 is going to be -8, because those two match up. I know my output for -3 is going to be -5. I know my output for -4 is going to be 0. Again, this only works, this mirroring, is because we started with the vertex in the middle. We could have just picked random x values and gone through, but then we would have had to done work in every single row. Now we're kind of cutting the amount of calculations we have to do in half. The last piece to check now is put this on a graph and make sure we get that distinct parabola U shape. So graphing this, our first point would be negative 4, 0. So to the left 4, I don't go up or down at all. Negative 3, negative 5. So I'm going to the left 3, down 5. Negative 2, negative 8. And my vertex point, negative 1, negative 9. I know at this point I should start going back up and filling in the other half of my parabola. So doing 0, negative 8. We can see our symmetry already happening. 1, negative 5, and 2, 0. And we're just going to, best we can, draw a smooth line through our points. So there's a completed graphing of a quadratic. This is like an essential skill. I would feel bad as a teacher if I didn't get you all the way to like doing this like perfect each time. So we're going to do 2 more examples together. This is something we need to know how to do. You always evaluate graphs and plugging things in. It's really just, are you able to do this part correctly each time? Because if our values are wrong, our graph's going to be wrong. So our values are important. All right, backside. Example B, I threw in some negatives. I made our A term negative and our B term negative. So I mentioned on Thursday that parentheses are going to be our friends. So we're going to make sure we're using those when we're plugging in our values. So we want to write our A value is negative 1. Our B value is negative 2. We're going to use those 2 values in our vertex formula. Again, I'll do my work down at the bottom. So vertex, x is equal to negative b over 2a. And not something you have to write each time, but I like having it there when I'm doing it up on the board. So we have this negative, and then for b, we're plugging in negative 2. All right. Protecting that negative 2 with the parentheses around it. Same thing with our a in the bottom. It's negative 1 using parentheses when we're plugging things in. So a negative and a negative on the top makes this a positive 2. On the bottom, we would have a negative 2. So again, our x value is going to be negative 1. So equal to negative 1. Your vertex point is not always going to be negative 1. It just happens that 2 examples in a row, our x-coordinate was negative 1. Just by coincidence. We use the negative 1 to find our y value. Again, I'm just going to write this so we can see where all of our pieces are going. Oop, this should be a minus 2. So especially with the negative in front of our a term, we have to have parentheses plugging in for x. So we would say y is equal to negative, then we're plugging in negative 1 for x, so it's negative 1 squared, minus 2 times negative 1, plus 3. When we're evaluating, we have a bunch of negatives. We just have to remember our order of operations. So looking at our first term, our negative 1 squared has to happen first. So negative 1 times negative 1 is positive 1. But then we have, again, this negative out in front. So it's like we're taking this positive 1 we got by squaring and then multiplying it by a negative 1. So our result is going to be negative 1. A negative 2 times negative 1 would be positive 2 because a negative times a negative is a positive. And then we add the plus 3 in the back. So -1 plus 2 is just 1. And we add 3 to that, we get 4. So our y value is 4. So that's going to fill in the middle of our table. Putting in our vertex first. -1, +4. That's your vertex. Think of your x values as just a number line. Count forward, then count backwards. So again, these are going to be the same values we just used. So 0, 1, and 2. And then -2, -3, -4. I'm going to take the same approach. I would much rather plug in 0s and 1s than -2s and -3s. So I'm going to fill in just the bottom of my table. So plugging in 0, we'd have -0 squared minus 2 times 0. And then it's plus 3. So remember, whenever we multiply something by 0, it stays 0. So -0 squared is 0. 2 times 0 is 0. So we have 0 plus 3. We get an output of +3. Let's do the same thing with 1 now. -1 squared minus 2 times 1 plus 3. So this would be 1, and then a negative. So we have -1 minus 2, so that's -3. So -3 plus 3, that's 0. Again, all this is just because it equals that. And then plugging in 2 now. -2 squared minus 2 times 2 plus 3. That would be equal to, we would get -8 plus 3, which would be -5. So again, don't do more work than you have to. Don't plug in -2, -3, -4. Use the values you already made. All right, remember, it's symmetrical. This is like where our axis of symmetry is. So you gotta tilt your head and look sideways. These two should match up, these two should match up, and so on. So it goes a 3, a 0, and a 5. Putting on a graph now, making sure it's just our U shape. -4, 5. Right here. -3, 0. -2. What did I do? Oh, -3, 0, -2. Oop, I messed up somewhere. -5, 0, 3, 4. Oh, I didn't do this. This should be -5. I didn't copy that one right. -5 up there. Because I got -5 down here. So it should match up. So this point has to move to down here. -4, -5. -3, 0, -2, 3, -1, 4. So there we have half of it. Now we mirror our points. 0, 3, 1 and 0, 2 and -5. So this one's opening down because our A term was negative. Just trying to draw a nice line through those. So we'll do one more together. If you feel like, hey, I got this, try the next one on your own and then compare it with what we get at the end, especially the values in the table. If you're not there yet, totally okay. We're going to spend maybe 2 days on this. Just keep following along and trying to think through yourself. Am I understanding each step and why I'm doing it? So looking at example C, the last one on that page, our A value is back to being positive. It's a positive 1. Our B value is still negative. It's negative 12, having awareness of that. Now let's find our vertex. Vertex. We could say x is negative b over 2a. So that's negative, then I'm plugging in negative 12 over 2 times 1. So as you remember, a double negative makes it something positive. So I have a positive 12 on the top, a positive 2 on the bottom. So 12 divided by 2 is 6. So my x-coordinate of my vertex is 6. If you want to put that in your table right away, just to like remind yourself, all right, what's the whole thing? You could even write vertex in the middle before you begin. So you know where things go. Now to find our y value, we're plugging in 6 wherever we see our x. So we'd have 6 squared minus 12 times 6 plus 32. So this would be 36 minus 72 plus 32. That would be y is equal to negative 4. There's our y value. Numbers are just a little bit bigger now. All right, nothing we can't handle. So our y value is negative 4. We'll put that in our table. So now to fill in the table, again, we're just going to count forwards and backwards. So it goes 6, 7, 8, 9. And then if we count backwards, 5, 4, 3. And here we could just use a little bit of judgment and think about, all right, what values are going to be easier to plug in? Like I said, all these are positives, so that's a good sign. But I would much rather plug in small positives opposed to big positives. 7, 8, and 9, they're not huge, but plugging in 5, 4, and 3 is a lot easier. So we're going to start 3, 4, and 5, plug those in, find our values for y, and then mirror our table. So we're taking, it would be 3 squared, which is 9, minus 12 times 3, which would be 36. So we add 32. So that would be equal to, here we get a positive 5. Again, let your calculator do the heavy lifting for you. They're doing that evaluation part. For our next row, we do 4 squared minus 12 times 4 plus 32. That will give us 0. And then we just have to do 5. 5 squared is 25 minus 12 times 5, which is 60. Then we add 32. That would be negative 3. Again, since we start with our vertex, we don't have to do any work in these three. We can use our work from our outputs to fill in. So it'll be negative 3, 0, and 5. Now putting these on a table. 3, 5, I'm going to the right 3, up 5. There's where my first point will lie. 4, 0. So we're going to the right 4, and we're just staying right there. 5, -3, so the right 5, down 3. Our vertex is 6, -4. 7, -3. Then we're at 8, 0. And then we're at 9, 5. Now nice swoop through our points, and we got our last quadratic.